What if the most evidence-based diet in the world wasn't actually about perfection, but about a few small metabolic switches that reprogram glucose handling, oxidative stress, immune behavior, and even how your cells respond to fat? The Mediterranean diet consistently shows up as one of the strongest dietary patterns in science, but not because it's magical, because it aligns with multiple systems at once: cardiovascular health, which surprisingly has a connection with the immune system, also lower all-cause mortality, improved metabolic markers, and better long-term body composition outcomes. But here's the real question: do you need to completely become Mediterranean to get Mediterranean benefits? Probably not. Instead, think of it as a 20% dietary input shift that drives 80% of the metabolic output. So, the first food here is going to be olive oil, because it affects the GLP-1 plus GLUT4, oxidative stress switch. In Mediterranean regions, olive oil can represent 20 to 30% of total calories. That's not a garnish, that's a metabolic substrate. Now, mechanistically, olive oil contains OEA, which is short for oleoethanolamide, which signals satiety pathways and improves fat utilization. This shifts the body towards fat oxidation, reducing reliance on glucose spikes that drive excess blood glucose, which increases advanced glycation end products formation, or AGEs for short. If you've seen my other videos, you already know that AGEs makes the ECM, short for extracellular matrix, way too stiff, and then the immune system or the immune cells cannot enter to attack the cancer cells, which are inside of the ECM. OEA and olive oil also affects early glycation products, such as amidori products. And because if the AGEs goes beyond the amidori products, then that leads to irreversible cross-linking of the ECM, or in other words, long-term ECM stiffening, or a rigid extracellular matrix. When the ECM becomes rigid, immune cells struggle to infiltrate tissues effectively, which matters in cancer surveillance and inflammation resolution. Meanwhile, olive oil intake has been shown to stimulate GLP-1 secretion, which indirectly enhances insulin response and supports GLUT4 translocation into muscle cells. That's important to get the blood sugar out of the bloodstream via the GLUT4. Because if it doesn't, then the blood sugar stays in the bloodstream creating inflammation, but also possibly a theory that tumors, they can actually feed on the blood glucose with the blood vessels. So tumors rely heavily on GLUT-mediated glucose uptake through blood vessels, especially under high circulating glucose conditions, or possibly diabetics. Because if diabetics are insulin resistant, then the blood is the sugar in the blood is not getting into the cells, and then the sugar stays out in the blood. So olive oil can also increases antioxidant capacity via polyphenols like hydroxytyrosol, supporting glutathione recycling systems, which help neutralize oxidative stress created by AGEs. The second food here is hard-aged cheeses, which contain C15 fats. So now I'm moving on to cheeses like Parmesan and Pecorino Romano. These are not just protein sources, they are biochemical signaling foods, because aged cheeses contain pre-digested proteins, phosphopeptides, which improve mineral absorption, that's critical there for the immune system, and high levels of C15, or pentadecanoic acid. So C15 is a saturated fat that integrates into cell membranes and helps stabilize them against oxidative damage. This matters because oxidative stress is one of the drivers of lipid peroxidation, ECM breakdown, and immune dysfunction. Now, immune cells don't run on one fuel, they switch. Activated immune cells rely on GLUT1 mediated glucose uptake. Also, fat-utilizing immune states rely on fatty acid transporters like FATP, short for fatty acid transport proteins. C15 influences membrane structure and signalosomes, which I've made videos on before. Signalosomes are lipid raft signaling hubs that regulate immune receptor activity. So that means that fatty acids are not just fuel, they are information carriers for immune signaling behavior. So when you add aged cheeses, you're influencing immune membrane composition, you're shifting fat versus glucose immune fuel preference, and you're indirectly modulating inflammatory signaling thresholds. And yes, this connects to ECM behavior too. Less inflammation pressure equals less ECM remodeling and fibrosis. On to food number 3, or a group of foods, is microbiome vegetables for glutathione, quercetin, and advanced glycation end product control. Mediterranean diets use unusual vegetables such as capers, artichokes, eggplant, okra, chicory, zucchini, and collard greens. These are not random, they act on redox biology and glycation control systems. Capers contain high quercetin, which upregulates endogenous antioxidant systems, supports glutathione regeneration, and reduces oxidative stress that accelerates age formation. So glutathione is critical for reducing advanced glycation end products so that the ECM is not so stiff and rigid with the cross-linking that the cancer or the immune cells cannot go in to attack the cancer cells, which I've mentioned a lot of times in previous videos. Next food is artichokes, contain inulin fibers, feeding microbiota that improve glucose regulation. That's critical because tumors are known for feeding on glucose. Artichokes also help insulin sensitivity and systemic inflammation balance. So lower inflammation means fewer circulating reactive sugars, reduced amyloid product formation, slowing downstream age accumulation. Lower inflammation also means a more citrulline for arginine. For T cells, T cells need arginine because high inflammation reduces citrulline. So that means a less energy substrate for T cells. Now that's critical because T cells, they need to switch between different energy substrates and not only focusing on just glucose or fats. So they can also use arginine. And ages are important because they stiffen ECM, impair immune infiltration, and ages also alter receptor signaling on immune and endothelial cells. Or in other words, ages could prevent immune cells from taking up energy substrates such as arginine through the receptors. So diet here is directly tied to tissue level mechanics. Even eggplant and okra act as low-calorie bulk substrates, glycemic dampeners, and gut transit modulators, all of which reduce glucose spikes, reducing GLUT-mediated pathological uptake pressure. Food number 4 here is oily fish, which have omega-3 involved in immune metabolism and glucose reprogramming. Eating fatty fish a few times per week, like salmon or sardines, shifts systemic metabolism. Large-scale studies show reductions in mortality risk with regular intake. But mechanistically, omega-3 fats integrate into immune cell membranes. If omega-3 fats reduce inflammatory cytokines, like interleukin-6 and TNF-alpha. If you've seen my other videos, interleukin-6 can cause iron trapped in macrophages. And omega-3 fats also alters FATP-mediated lipid uptake behavior on immune cells. This matters because immune cells constantly decide, do I burn glucose through GLUT pathways or switch to fatty acid oxidation? So omega-3s bias immune cells toward reduced inflammatory glycolysis, improved mitochondrial fatty acid oxidation, and lower chronic immune activation. So omega-3s are good for autoimmunity, which is excessive T cells attacking healthy body tissue. So omega-3s indirectly reduces systemic glucose demands, lowering blood glucose exposure that feeds advanced glycation end product formation, tumor glycolysis, and ECM stiffening processes. And food number 5 here is Mediterranean spices. Now, the most underrated part, which would be the spices, such as basil, rosemary, thyme, oregano, and sage. These aren't flavor, they are transcriptional modulators. Rosemary compounds affect carbohydrate enzymes, downregulating alpha amylase and reducing alpha glucosidase activity. That means slower carbohydrate breakdown, reduced glucose spikes, and reduced GLUT-mediated overload in blood. So that means that rosemary could be a good spice for diabetics, because less glucose spike means fewer ages equals less ECM rigidity equals improved immune access by immune cells to tissues. And even more advanced, compounds in rosemary, thyme, and sage increase PPAR-α activity, a nuclear receptor that shifts cells toward fat oxidation and reduces reliance on glucose metabolism. These compounds also reduce interleukin-6 and TNF-alpha, allowing iron availability for vitamin A for intrinsic factor, so that vitamin B12 is functional, which I've already mentioned in many of my other videos. So IL-6 and TNF-alpha are key inflammatory cytokines involved in ECM remodeling and immune dysfunction. So you don't need a perfect Mediterranean diet. You need better fat signaling, lower glucose volatility, improved immune fuel flexibility, or in other words, switching between different energy substrates such as glucose, fats, amino acids, protein. You also need a reduced glycation pressure on tissues and a microbiome that supports metabolic stability. That's what these small 20% changes actually do in your diet. They change cellular behavior, immune metabolism, and tissue structure over time. I'll see you in the next video.